inconvenience with the Zoom. I always forget which group it was. I thought it was some group on Tuesday, and I kind of. And then I think my emails reach you like yeah, not immediately. Yeah. Now let's start. So we are doing this data-related things today. Now we will have. Last time we finished on this part C, I guess, of the task sheet, and today we'll do something kind of related, a bit more. I can't say advanced, but like a bit something a bit newer. Let's call it this way. All right. So now. All right, if you didn't finish the part C entirely, I think it's fine. You already know how to do these things more or less. All right. So today we work with a different file. We work with this file R25H, not I. As last time, so we have the household level data. Remember, I told you, and this is like the multi-purpose survey, multi-purpose data. So sometimes we don't know what people will do with it. So like it can be used for many purposes, and that's why you never know which data people will need. And sometimes some data. Some variables are easier to store at the different levels. What does it mean? It means that, like, for example, age is an individual characteristic. Yeah, like age of a person. This is what you know. Yeah, you can't calculate the age at the level of the household. It doesn't make any sense. However, some things, like income, for example, are more convenient to store at the household level. I will send you, yes. I think I've sent you last time, no? Oh, wow. You should have told me. Once again, doesn't harm me. Right, so now we are working with the last file, like the last file I've sent. So income is easier to store at the household level. Why? So like, now it's my question. Why is it easier to store income at the household level? Not individual one, but at the level of the whole household. So what are the kind of ideas there? Easier to count? Yes, less data. That's kind of good thing, because yeah, like instead of having income for everybody in the data set, we have it only for the family. Yeah, and also besides this convenience of storage, yeah, like how much space it occupies and so on, it's also probably more informative this way. You remember last time we said that, like, we looked at the data and there were, for example, little children, yeah, like babies. Maybe it's easier to count, to calculate income for the whole household, because if you're a newborn baby, it doesn't mean that you're poor. Because you remember from the lecture that poverty is not when you have no money. No, it's when you're deprived in your well-being. And maybe as a child you are not deprived if you have no income. Actually, it's the opposite normally. If you have to work as a child, then something is kind of not entirely correct. That's why it makes sense to look at the level of the household to see how much income each person gets instead of how much income each person earns. Quite often these are the same things, but yeah, sometimes. So yeah, how do we determine a household? We determine it as like a family. Yeah, so like how it's done on practice. Yeah, so like on practice, these enumerators, so enumerators are people who conduct these interviews. They normally come to a place where people live, so like to a flat, for example, and they say like, all right, could you, and they interview sometimes one person, sometimes several people. But for example, imagine they come and there's only one person. They say like, all right, could you please tell us who lives here? Are you living alone? And then the person says, for example, no, I didn't live alone. I have like a family, but they're not here now. They just went for a walk. Yeah, like that's possible. Sometimes it's one person. Sometimes it's only one person. So that's like depends on the household, but like household is basically a one place of residence. Yeah, a family or a single person, but like basically one. Let's say like one flat is one household. I think if you share a flat with somebody, it could also be a household. I'm not entirely sure about these things, but like most of the time, yes. All right. So now we said we study income. We do it at the household level. So now let's do something about it. Yeah, like so now we can look at the income variables. So we remember it's sum is the first command we do when we want to learn something about the data. And income here is called UF14. What does UF14 means? We can look at the label, and label explains it pretty well. So it's the total income of a family in the last 30 days. Yeah, that's something to kind of remember. So in the last month, basically, how much money your whole family earned. We hit enter, and we get some statistics. So observations. Observations are 4,800. If you remember this previous data file, you'll see that there the number of observations was 12,000. Yeah, so here it's 4,000, like 5,000. There it's more than 12,000. Why do we have such a difference? Because there we had individual data. Here is the household data. So basically, individuals can live in the same household, and number of families is kind of fixed, is unique. Yeah, like it's only one family in this household level data. Yes. Minimum is 0. It's kind of it doesn't look realistic. Yeah, we see like so observation just tells us how many lines we have in the data table, and we know that each line is the one observation, one household. How do we know this? We can write code book F14, and it tells us, all right. Sorry, not UF14. Sorry, it was wrong. UID, and then it tells us all of them are unique. So like each line is a unique number. To the median will come soon. So now we start with the mean. And you rightfully said that maximum is super weird. Maximum is weird. And the mean, exactly. Oh, really, you see the point? Like, yeah, I don't have to pull it out. Exactly. So these are Russian rubles. These are Russian rubles, and you see the mean is again quite high, 3.5 million per month per household. Yeah, like in the places where I'm from, that's super high. It's kind of not realistically high, because you remember that the RLMS is the nationally representative household. So maybe there's something else. There's something wrong with the numbers. If we want to see what the what is our next step, to see what's wrong with the data, we see like, oh, we look at these numbers and we see they are blue again. So somebody, these values are labeled again. Why do you need to label income? That's already suspicious. And then we see already in the first kind of page that somebody refused to answer. And you remember the same as with age, refusing to answer is encoded with something like very, very, very high. Something like unrealistic number. It doesn't mean 0. It means that the person told this enumerator, said like, I will not tell you my income. I will not tell you my income. And that's why people who kind of then process the data, they say like, all right, we encode it with something very implausibly high. Why is it done this way and not just dropped or something? Because I told you it's a multi-purpose survey. So like we don't know who will be using it and what for. Imagine you want to study something like trust in the society. And one of these measures of trust, yeah, like if person trusts you to tell you their income. Yeah, for example, yeah, it's a matter of trust. If, for example, you ask your friends, sometimes, yeah, like what's their income? Yeah, like if they trust you, they will tell you. If we want to see how these codes, what codes do we have in general? So we now know that, all right, there are some codes, technical codes. Why do we have them? Because data doesn't allow for text in numeric variables. So basically, these are numbers. Income, yeah, it's measured how many rubles you have. This is your income. Here, somebody said like, I refuse to answer, and we want to see what other options there were. You remember we go to these variables, like on the right we have this variable value manager, sorry. And here we see like we have 3 options. So what should we do with these numbers? I'll show you in a second. So we see that people say like, all right, some people say, I cannot answer. Imagine it was like a, like a reckless guy of who doesn't know how much his parents earn. So he's 18, 19, but he just doesn't know. He says like, all right, I don't know, it's enough, I got enough, I don't know what's the total income. I don't know, for example, how much, for example, it could be me, I don't know how much my parents earn. I never kind of asked. And some people said like, some people know, and they say like, no, I will not tell you. Yeah, like kind of a bit impolite, but like, yeah, that's the right. And the last thing is no answer. I don't know. Maybe the person just, the interview was interrupted at this point and they had to finish it. So we basically here, we label not all of them, we label only these 3 codes. Only 3 codes, but Stata says that like, all right, all of them are blue now because this is the labeled variable. And it has actually values, like only 3 labels for values and not that much as they actually are. How do we get the number of times some data appears in the data set? We can replace the label. Of course, we can add the new label or edit this label or something else. Yes, somebody answered no. So now we say like, all right, we don't know why people refuse to answer. What if somebody wants to study this? That's kind of another research question. We want to study poverty. That's why we cannot include these observations in our analysis, because they spoil the whole picture. And that's why we go back to this output window, and now we decide what we want to do with it. So we can drop them. Yeah, that's one option. Another option would be, for example, to somebody said like we could substitute it with the mean. Yes, that's an option, but at the same time, if you replace something with the mean, you already make some assumptions. Yeah, like you say like, all right, it should be equal to the mean and not smaller or not larger. So you kind of center the data around the mean, which might be not the case. And it's not 0, because some people, you see, like some people said it's equal to 0, so they have 0 income, which might be not true. Actually, we should actually use it as a missing, because we actually have missing data. We know what people said about the income. They said like either I don't know or I refuse to answer, and this information can be used by somebody. For our research question, we cannot use it. It doesn't help us. However, we can replace it to dot immediately. This is one option. Let's say I want to keep this information for later. What if I'm afraid to delete the things? Like some people are afraid to delete things. That's why we can just say like, all right, I want to generate a new variable, which I'll call family income, and it's equal to year 14. So you see, like it's the same variable. So there's a perfect clones of each other. However, this family income, we know we generated it, so we can be a bit more like easy with it, because we know like if something goes wrong, we can always delete it. We have the initial data still there. There are not only 2 options. There are, you see, like your colleagues also offered something else. So like replace it with a 0, replace it with a mean. All these options are kind of, we can do this technically, but every time you do this, you have to think about, should I do this? And what does it lead to? These are kind of neutral. Like replacing with a dot, for example, like it's a neutral thing, because we can say like, all right, it's missing data. People are still in the sample, but households, we are not talking about people now in this data set. We're talking about households like families. All right, so we say like, let's replace it to missing. So now we say like, all right, I want to replace family income. It should be equal to 0 now. Oh, sorry. I was telling you like, no, it's not 0, it's missing. We say like, it should be missing if this UF14 is bigger than this huge number. So like we include all these three codes, super huge codes, it should be replaced to missing. But some of you was suspicious about income equal to, I think the first code starts with 7, so I just put 6, so like one digit before. Some of your colleagues was suspicious about income of 0. Yeah, like it could happen. It could happen. I agree that maybe some people, you know, like maybe this was a guy who is a sailor. You know, like sailors who go like to these long journeys, they spend like half a year in the sea and they get a lot of money, and the remaining half of the year, they just stay on the shore and relax. Maybe. However, we don't have many sailors actually, yeah? So maybe this person is also lying. Yeah, like it's possible. Maybe this person is like like we don't know. We don't know. This is not asked. Or maybe there was a question actually in the whole data set, like what do your parents do? Here we have only this data, but let's imagine it's more like now I'm showing you how to play with the theta functionality. So this symbol, this like vertical dash, is the OR operator. So like it's an OR in the condition. And so like, all right, I don't trust people who said that the income is equal to 0. I don't believe it. Well, in reality, it could happen. Yes, like in reality, we could keep them. But let's say like I don't believe them. So it's suspicious. I say they're lying to me. I don't want to have them here. Because all this survey data, it's normally self-reported. So people can lie. People can lie. You cannot check it in any way. However, let's say you say like, all right, I believe it's this person is kind of lying to me. I hit enter, and theta made 173 changes. So 173 changes, and all of them are now missing. So basically 173 observations are missing out of 4,800 something. Yeah, exactly. So maybe like 0 doesn't tell us much again about income because we cannot see if it's enough or not. So yeah, maybe the guy just receives money not very regularly, but yeah. So this vertical dash, it's an OR operator. Under the present delta. These are numbers, these are just this shows the distribution. Yes, like says like the 10% of our sample, 10% of our sample receives 14, how much? No, it's the ID. All right, it says like 10% of our sample have their ID equal to 14, no, how much? 140,000, 43, and smaller. So yeah, it just shows the distribution. It's just the number. It's the number. It doesn't tell us anything. Family income. So now we can see how does it look like now. We can sum family income, and that's what we see. It's much more realistic. First of all, like we see that number of observations is slightly lower because 173 are now missing. They are not included here. And we see like the mean is 47,000. All right. Maximum is like, it's 1 million. Yeah, like it's not very unrealistic. Yeah, like I could imagine this. Yeah, like 1 million rubles per month. That can happen. I could imagine this. Yeah. At least, like, yeah, it's not very unrealistic. However, minimum is still weird, yeah. So like we just said, like we don't believe those who said 0, but yeah, 600 is also weird. I agree. We'll just keep it this way. 600 rubles per month, yeah, probably it's very little. It's income for last 30 days, so last month. All right, so exactly, but maybe this money is not very lucrative because if you have more people in the household, you have more people who can earn, but at the same time they also have to share it with other people, so they have to feed also more. So now we can sum. We have the variable u and fm, number of family members, and we see that on average we have like 2.5 people in the household. Minimum is 1, maximum is 16. All right, so now of course it makes sense to look at not the aggregate number, but at the per capita numbers. Yeah, so all right, who can help me with the code? So we need to generate per capita income. So U and FM is like number of family members, number of people living in the household, the number of people who share this income. Yeah, maximum value is all right, like it's 16. Just a big family. I've seen this on the TV about people who have even more kids and so on. It's a household, yeah, like it's a household. It's not just a family. It's a household. So yes, one person living alone. So why not? Yes, exactly. So we generate variable called family income. Oh no, sorry. It's per capita income equal to family income divided by this u. See, like it tells us that it created 173 missing values. So it could create the value for all the data set except these 173. Why it couldn't? Because it doesn't know the family income of these 173 households, so it ignores them. Yes, tells them, all right, per capita income will also be missing because I cannot do anything about it. All right, so now we have we have non-integer numbers because we have these are means. Yes, like it's kind of a mean number. So like actually in all households they are integers, but when you calculate the means and standard deviations, that's possible. All right, now we can sum it per capita income, and here things look not very nice for us as Russian citizens, but at the same time very realistic. So the mean per capita income is like 19,000 rubles. So basically we see that, yeah, maybe people are not very rich. I can't say mean is better. No, I think actually median would be better statistics here in this case. Yes, fam inc and family income are not different. Stata just wants an identifier until the moment that it understands what variable I mean. So here I could just write f because it's only one variable with f. For example, I can write sum p, and it understands per capita income because it's only one variable starting with p. At the same time, if I write sum u, it's like I don't understand which u you mean. UID, U dash NFM, UF, then Stata kind of tells us, all right, I don't understand, what do you mean? All right, per capita income. So we see like, yeah, we have some maximums like 290, that's all right. Minimum is that amount, so, all right. You said like you were asking about mean and the median, the difference. Another way to ask for per capita income, and so like to analyze some statistics, if you want to analyze these statistics, we can tell Stata to give us some table with statistics. Oh, sorry, that's what tab stat means, of per capita income. And then we, in the option, we say like, all right, we want number of observations, mean, standard error of the mean, standard deviation, median. So P50 is median, minimum and maximum. So look at this. So like, yeah, I shorten the variables quite often. I honestly, like when I work with my data, I don't give the names very long, so that's why I don't even shorten, because they're already shortened. Here it's more, be more explicit to understand what we have done. Yes, so mean could be sometimes misleading, because the median tells you here. Yeah, what does it tell us? It tells us that half of our sample earns 15,900 and less. So this is like, so we can say that half of our population lives on this money and something less. Half of our population lives on something more. So we see like the middle distribution. Mean, we see like that the mean is actually larger than the median. It means that our distribution is not normal. So it's pulled up a bit by these super high numbers. So if you remember when we talked about inequality, yeah, mean can be misleading in the sense that imagine that everybody lives on like $1, and we have one guy who has $1 million. The average will be like something okay, but at the same time, we know that we have a very poor nation. So that's why median in these income comparisons is actually much is better, because it's not, because we have lower bound 0, it's fixed, and the upper bound is not fixed. It could like go to infinity. That's why we have better to operate with the median in this type of comparisons. So what does SE mean? It means that it's standard error of the mean. Oh, yes. So basically it tells us how sure we are that our mean is this value and not something else. And we say like, all right, it's mean plus minus 226 rubles. We kind of know what's the mean for sure. Yes, everything is in rubles here. Everything is in rubles. So if we deleted the variable that we want, so if we want to delete the variable, we can just write drop and the name of this variable, and it will kind of drop it. All right. How to interpret this? I honestly don't know how to interpret. I wouldn't interpret this at all. It's yeah, I guess for some other tasks you might need it. Here I don't see any reason why you should interpret this and use it at all. So it's kind of, because we're calculating the summary statistics of a deterministic variable. They are measured, they're not predicted or something. So I think for predicted variables you can use it, and then you can say like how well I predict this. But here no, just use this. It's just to show you what state it can do. Right? Any other indices into the bracket. Here, yeah, we could do other statistics. If you write help tab stat, it will tell you what it can do. All right. So now we want to analyze poverty. Yeah? So now we are already almost there, but let's think about our data. So we have data about households, and you remember that some households have like one person, some households have 16 people. All right, so maybe we want to calculate poverty rate not among households but among people. Yeah, that makes sense. And we want to analyze it kind of disaggregated with some features and whatever. So now we basically have to combine two types of data sets. So we need to combine this data that we have now open, the household level data. We want to combine it with our individual data. So for example, let's say like our task now is to analyze poverty between males and females. We want to have it separately for males and females. Yeah, why not? It's interesting to see which gender is more deprived in Russia. That's why we need to combine the two. Now it's a bit of notation. So the file that we have opened now, so like this file R25H, is called the master data. It's only called master because we have it open now. If we open individual data set, we would say like that individual will be master. We started with this household, that's why we kind of want to keep it and so on. So we say like this is our master data set and we want to merge it. That's how like files are combined. Want to merge it with the individual data. So you remember this like household ID is the unique value. It's a unique characteristic of each household. Right now, just to remind you, not this one, this one. Now, just to remind you of the individual data, I open the individual data. And this individual data also has this variable UIDH. So it has the same variable in it. And if we look at it, we see that it has the same number of unique values as the household data, but at the same time we have way more observations. What does it mean? It means that if we look at the table, we see that some households are represented in the survey by one person. So this household here, like it's only one female. Here it's only one person. All right. So why not? It's possible. But here we have 3 people living in the same household. So their household number is the same because they're one family. Quite likely, yeah. Like we have a male and a female and their daughter, most likely, yeah. So why not? That happens. However, we see that this household ID is not unique in this data file. So it duplicates sometimes because our unit of analysis in this file, this individual data file, is one person. While in the household level, one unit of analysis is a household, is a family. So no, it doesn't mean that one household is one family. Oh, sorry, is one person. Here, for example, one household is 3 people. Here, yes, one household, one person. So it depends. It depends. That's why I have to be a bit careful about merging. But we know that, all right, in this data file, this ID thing also exists. All right. And close it. And it also, of course, exists. It's present in the household level data. Yes, it is enough. It is enough. Like it's 5,000 households. It's 5,000 families. Yeah, think about this. Actually, in Russia we have less than 145 million families. Yeah, so like we have, I don't know how many million families we have, how many million households, but something like maybe 30 million. Yeah, and then we have 12,000 people, and if you select them carefully, it's enough. But you have to do this like the whole science how to select these people. We won't do auto join. This is something from Python, but as I understood, like yes, it's some merge is something like this. All right, so we'll use the merge command. So basically now we go to this menu with data on the data tab. So like, all right, what do we want to do? We want to combine data sets. And we do this with the merge command. This merge command, we have to choose the key variable. So key variable is the one that connects data in both data files. So basically, it tells us, all right, this UID, so household ID, is the one that allows us to understand what has to be meshed with what. And we choose this name of the file, this individual data. You remember it's called using data. Using data, we have now opened the master data. And here we have different types of merge. I say one-to-one. It tells us that one household entry has to be linked with one entry from the individual data set. And if we put OK, Stata gives us an error. Why? Because it tells us that this variable, the household ID, doesn't uniquely identify observations in the using data. Yes, if variables are called differently, you have to change the name. So the names have to be the same. So that's kind of one problem. So you have to just call them the same way. Variable UID, we know that it's unique in this master data set, but in using thing, it's not. So in the using data file, Stata is confused. It doesn't know to which observation, for example, if you have a family, to whom attribute this income. We don't even need to change them. We need to change the merge style. Instead of one-to-one, we say like we actually want to one-to-many, exactly. Because it tells us that one household, information about one household has to be replicated to several individuals from the using data set. We can use 2 different data sets at the same time, but we have to open them in different windows. Yeah, so like No. So it basically every time you have it open new. What's the picture there? All right. Oh, this is a meme. Oh, all right. It's very annoying that you have to, like download it and like open it, and then and then it wasn't even that kind of impressive. All right, coming back to our data. So we say like now we merge one household observation with many individuals because we have basically same information in this file, which is similar for all family members. It's per capita income and total income of your family. So everybody in the same family have it the same. So we just hit enter, and now it worked. Now it worked. Moreover, it matched everything precisely. So all observations are matched now. And you see now we have 12,554 observations which are matched. So basically, you remember, we started with like 4,000, now it's 12,000. It's the number of individuals in the data set. All right. So now I'll show you now what we have, what we received in the end. So first of all, we see on the right that before we had only like 5 variables. Now we have another 4 from the individual data, and we also have this one merge variable. It's actually a technical code which Stata creates. Now it's created by this data. Not for the method used. It's a bit different. It tells us that all observations found a pair. Basically, it says that like all households found members. It's their members in the using data file, in the individual data file, and at the same time, all individuals found the incomes from the master data set. That's why merge is equal to 3. So it means that like we have a perfect match. Sometimes we can have other types of merge result. So like if merge is equal to 1, it means that observation is present in the master data, but there was nothing about this household in the using data. So for example, there was like no data about individuals from this household. Merge equal to 2 means the same, but like this means that like it was in the using data, but not in the master data. All right, then it's equal to 2. Here we have no such things. Everything kind of merged. That's why we have only equal to 3. And that's why we can remove this merge command, merge variable. Yeah, we don't need it because it doesn't give us any information. It already told us everything worked well. You have information about income and about individuals combined. That's why we can drop it. We drop it so that it doesn't occupy space because it's a technical indicator. Observations. All observations are matched, and variables are, we have this. Now list of variables combined from both datasets. So we drop merge. Now it's removed. All right. Now we can take a look at the data. How does it look? What did we get actually? So now we have all right. We don't add up all indicators for individuals, because we know, wait, I have to go back. You see, like now the table was like in kind of chaotic order. Let's say I want to sort it according to UID. So basically now I sort the table according to this ID. So like first ID goes first. Now let me show you on the table. I think it will be easier to understand what we have done. So basically this blue part, this blue part is the information from the household data. Yeah, this is household level data. The white part is the individual data. These are individual characteristics. And for some observations, it was easy to match. So there was one person, it was one person, this highlighted part, it's the only person in this household, so that's why everything was easy to match. So like there's one entry about the household, one entry about the individual, they are very easy to match. Number 2, 3 are also quite easy, 4, but for household number 10,016, things are a bit more complicated. So in the using data set, we had this information. So this is our individual information about 4 individuals. Yeah, like most likely it's a family. Yeah, like we see, like we have 2 adults and 2 kids. All right, and we knew that they were living in the same household. They have the same household number. So this highlighted part was in the individual data. And this part, which I highlight now, was in the master data, was in the household level data. So we knew that there is a household, it consists of 4 people, their total income is 68,000, and per capita it translates into 17,000. All right, that's good. Per capita is like somehow type of residence, so like the place where people live is called status here. I don't know why, but it's basically a type of residence, so like where people live, in which type of city, or town, or village, or so on. So in the household level data, we had this information, and we had to connect it to these 4 observations. So when we said like merge 1-to-1, Stata was confused to which one of the 4 it has to attach this data. But when I said like merge 1-to-many, Stata understood, all right, I take this line, this information, and I replicate it for all people who live in this household, because it's the same. Yeah, like total income of the household is the same for every one of them because they share it, and that's also translates into the per capita income, which also will be the same. So basically we took, no, it's actually good. So we took this information and replicated for these 4 entries of the individual data. And now we know that, for example, there is a guy, like little boy living in some городского типа, whose per capita income is 17,000. All right. Yes, it's a result. So we combined 2 tables into one. So now we have one table, one big table, instead of 2 kind of smaller tables. This weight basically means how many people this observation represents. So this guy, for example, represents, it's normalized, so it tells us that, you know, like slightly overrepresented in the data, in the sample. All right, so now we can use this data to actually do something about poverty. Yes, that's what we'll do now. We'll do poverty by gender. So we can start. How do we see poverty? Sorry, we have to create the poverty line, the poverty indicator. No, master was the household level. Master was the household. Individual was the using. So we stayed in the using. We don't save it yet, but if we save, it will be saved for the household level. Yeah, not for the individual. Right, now we want to create this the poverty measure, some poverty indicator first. So we have to generate a new variable. So we generate poor equal to, I say poor equal to 1. So we create a binary indicator. So who is poor and who is not? Yes or no? So you are yes, poor, if, let's say if your per capita income is smaller than 9,691. For example, yeah, like let's imagine that these are our, this is our criteria. And it's a bit more technical aspect here. All right, about the merging. So we had one master data file was the household. So we said like I want to replicate one observation of the household and then merge it to many individuals in the using data set. Yeah, so we said like I have one household entry. So this is one, and I merge it with many entries in the individual data set. So basically take it one, replicate it, and connect it to many individuals all living in the same household. All right. So Stata is a bit, I can't say stupid, it's very formal. So it doesn't understand if your data is missing. Is it smaller than this level or is it bigger? It doesn't understand because missing at the same time. So merge equal to 3 means that we have all observations matched. So we have no observations that didn't found a corresponding entry in another data file. So everything worked super well. All right. So that's why we have to tell Stata that the income data is not missing, because for those for whom income is missing, we cannot say if they're poor or not. We don't know actually their income. We say per capita income is not missing, like is not equal to missing. Like that's what we do. And I said like, all right, yeah, it generated 10,000 missing values. What does it mean? It means that like it created 12,554 minus 10,063 observations with poor equal to 1, because we told Stata these are poor. We didn't tell Stata what to do with the rest. So now we tell it replace poor equal to 0 if per capita income bigger than 9,691, or let's say bigger or equal. Yeah. And at the same time, per capita income is not missing. So now we replace, basically, they are missing, Stata doesn't know what to do with these people. We say like, all right, these people are not poor. These people have income above this line. So this number, 9,691, was the poverty line at some point in Russia. Now it's 10,000 something. This was kind of now it's kind of the yeah. So this is, at some point it was this number. We just use it as a reference here. Can we use else if? Well, I'm just trying to think what was it for. Yes. So I just said like, yeah, we just use if, and then we put two conditions. So like both of them have to be. Yes, that's why why we put and. So it's like if this condition is fulfilled and this condition is fulfilled. So kind of both of them have to work. We hit enter. Oh. All right. You have to, yes. You have to substitute. And you see, like it made 9,475 changes, but yeah, it didn't replace all missings because you remember we had 173 households who didn't tell us their income. Some of these households were not single, so there were other people living besides one person. That's why I have now 588 people already, not households, for whom we don't know their income status. All right, so we can now calculate our poverty rate. We say tab poor, and this command just shows us all unique values of this poor variable, and we know what they are. They are 0 and 1. These are our poor values. And we see, so now in our sample, we have 2,500 people who are poor, and 9,500 who are not poor. In percentage, it translates into 21% who are poor, 79% who are not poor. All right, something already kind of useful. No. Yes. So you see, like, we have like total number of people for whom we know their poverty status is equal to 11,166. Total number of observations is larger. It's 12,554. So for 588 individuals, we don't know their poverty status. That's why they're not included here. They're kind of ignored. All right. Now we can exploit other functionalities of data. So the by sort command tells us to sort the data according to this. So the dot always means that it's missing. Like if income is not equal to a dot, it means it's not missing. So we have actual information about it. So by sort. By sort is the command that sorts the data and runs. The cumulative is cumulative distribution. So it tells us what share of population population lives there, or like not only lives there, but what share of population kind of belongs in the groups listed so far. Cumulative distribution. Here it's the same as the relative because we have the two categories. if I had like more, we would have like, so for example here 100, it means that 100% of our sample either poor or non-poor out of those who we have status about. That's kind of roughly to think of this. So by sort. By sort is the command that allows us to calculate something separately for different characteristics. Let's say we want to calculate poverty rate separately for gender. Remember, this H5 is our total. Oh, sorry, is our gender variable. So we say like, all right, sort the data according to this variable and calculate and present us the table about the distribution of variable poor. And we see like, all right, now it creates us these summary statistics separately for males and females. Right, and then we see like, all right, out of males, 22% of males are poor, 78 are not poor. All right. At the same time, 80% of females are not poor, and 20% of females are poor. So that's already something that we can analyze. We see that women are relatively less poor, but at the same time, there are more in absolute values. There are more poor women than men. Somehow we can think about it. Yeah, we can analyze. This is about gender. We can do the same thing with like other categorical variables. So for example, status. We can have more poverty categories, yes, than two, if you want to say like this is people extremely poor, this is not so poor, and so on. What do we make percent of? So like we basically here, in this example, I think it will be easier to see. So here, we know that in this Областной center, we have close to 5,000 people living. Out of those, who we know their income status. So here we know that like we know income of 4,878 people living in Областной center. Out of those, 4,390 are not poor, 488 are poor. So poverty rate in the Областной center is 10%. So poverty rate in these large cities is 10%. So like this kind of double dot here is just like, yeah, it just tells that you separate. So like you say like, all right, I do this separately for all unique values of status. And then you say like, what actually you want to do? And say like, I want to tabulate poor. All right, in kind of smaller cities. We see that the poverty rate is a bit higher, and it increases the smaller type of residence we have. And we see that in villages, it's super high. In villages, it's like 38%. All right, that's probably something to think about. We could also analyze, for example, where do poor people live in absolute numbers. So here, we see that villages have as many poor people as all three types of residents combined. Yeah, so another thing to kind of consider. And so on and so on. So like this by sort command is very useful for separating the data file and calculating something separately for different characteristics. Now we know actually how many people are poor in absolute numbers, but let's imagine that we want to save this value for later. That's why we can say like we want to calculate the head count. You remember the head count, poverty head count? It's the number of people who are poor. Just a raw number. All right, how does this by sort command works? So we say like, all right, I want, so like if you say like by sort UH5, you say like I want to sort the data by this variable. Yeah, like separate between different unique values of UH5. So UH5 has only 2 unique values. So it's 1 or 2, male or female. So for each unique value, I want to tabulate poor differently, separately. For status, I'll have 4 categories, 4 unique values. So I'll create it for all 4 of them. Coming back to our head count, egen is the command that generates the new variable, but using not these very simple mathematical operators as gen. So gen uses plus, minus, log, power, divide, multiply, and so on. If yes or no, egen employs some functions which Theta kind of has inside. So here I'll say I want to create a variable called head count, which is equal to, and now I say like which function I want to use. Total. And this function total is basically tells us that I want to create a sum of all observations of a given variable. So for example, if I want to calculate the total income of our sample, decide that I want to have a GDP of the sample. I don't know why can we need it, but like imagine this. Then I'll do total for income, and then I'll have like I'll know how much money overall this data sample gets. Here I use poor, and it's much easier because like poor is 0 or 1, so like those who are poor are counted with 1, and that's why if I sum up all number of ones, I'll get the number of people who are poor. So egen is just the way to tell Theta that it will have to utilize some built-in function. Built-in function which already Theta knows. So if you type help egen, Theta will give you a list of all functions that it knows. So total is equal to sum. If you write it in Excel, like below the table, you say like sum and then all values above. This is exactly what total would do. So it sums up all values of a variable from different observations. So we did it, and now if we sum head count, we'll see that actually now it created for all observations in our data sample, even those who we didn't know what the income was, it created this head count. So basically every entry now, every observation tells us that overall in the data set we have 2,491 poor person. How do we use it? That's already our kind of problem. So we know already this is the number of poor people in our data set. We saw this when we just tapped poor. So I'm just showing you how these functions work, but you already knew this thing before. Now, if you want to generate poverty rate, I just say like head count divided by 11,966. this is the number of observations for whom we know the poverty status. So we cannot divide it by the total number. We have to divide by only these people who we know what the poverty status is. Enter. If we sum, again, it creates it for all observations. If we sum this, if we use the sum command, we see like the mean is equal to 20, roughly 21%. Yeah, like standard deviation is 0 because it's the same for all observations. Minimum, maximum are also the same. And this is exactly what we had here. 20%, 0.8. All right. This is just another way to calculate the poverty rate. Yes, yes. No, not with your countries. No, not with your countries. You have all one country. The one country, which will be Togo. Even though it's not the actual Togo, I couldn't find the data which I would like, which would be easy to work with. That's why I simulated it. So if you have something about Togo, it's not really how they live there, it's how I decided that they should live. Yeah, so, but it's easier to work with like simulated data because it's kind of clean and nice. Basically yes, you have to, you know, all the commands and use a bit of your like intellectual skill, but in a very moderate amount, and it won't be connected to the code or something. It will be more like how to analyze data. You won't have to even merge it or something. No, it will be very simple. You have to analyze it using very primitive commands, so to say, and these operators. Right, the last thing I wanted to show you, we saw that like our poverty rate here was like, which we used, was around like $120. If you think about international poverty line is almost 2 times smaller. It's $2 per day. Here we have like around $4 per day. What if we want to say like, right, Russia shouldn't be actually thinking about international poverty line, which is correct, because we are much more advanced and kind of lucky country. We shouldn't refer to this international poverty line. We should have like our own poverty line. Use poverty line, which will be relative from our sample. If you want to use something about like data courses, you could actually think about, actually, if you have any questions about data, it's surprising, it's not like I'm lazy to tell you, but Google is very, very actually good at giving you the right answers, because this Stack Overflow or Stata List, it's another forum, they are super populous. There are so many people there. They exchange ideas and questions. That's why Google is actually very, very helpful at looking the answers that you have to Stata, because so many people work with it and people asked it. So for example, yeah, there are other forums which are not as useful. Here it's like everything that you want to know. If you have any question, you can always Google it and it will be super, super efficient. So I use it very often. All right. So last thing, let's say we want to say like everybody who is 60% below the median is poor. All right. So now we can say like, all right, I want to sum per capita income. Oh, sorry. With some details. And here we say like, all right, this is our median, 15,000. Let's say these are scalars. Yeah, like one value, it's not a vector. Let's say I want to save them somehow in the memory. Stated will forget it the next time you hit sum for any new other variable. That's why I said like I want to see how scalars are called. It gives me the list. So like, all right, I want to save the scalar called R250. So I say like, all right, I define scalar equal called median income equal to this. If I forget it, I can always say like display median of it doesn't understand it properly. All right, median income, and it tells me 15,000. If you forgot, it's 15,000. All right, and now I just say like, all right, I generate relative poor equal to per capita income with this condition. Yeah, so per capita income is smaller than 0.6 of median income. Yes, return list, it just shows us what scalars are now stored in the memory of Stata, which were used for generating this table. So remember these conditions, like in the brackets, I said like, yeah, if it's fulfilled, relative poor will be 1, 0 otherwise. And we do this only if per capita income is not equal to missing. 588 are missing. We don't know the income. The rest is there. The rest we know. And if we tab relatively poor, we'll see that now the way we define poverty rate now is a bit kind of underestimates poverty. Yeah, like now we say like, right, only 17.5% are poor if we define poverty this way. And that's already like the concept how we should define poverty, relative poverty. That's already like so much about even politics, yeah, like how you want to see it. All right, that's it from my side. So I will, yeah, kind of told you everything I wanted to. I think tomorrow you'll get I guess like evening, you'll get your last assignment. And there will be like data, a big list of tasks you have to fulfill, and then you just have to submit the do file where you write commands. And remember, like if you have this thing open, you just say like you open the do file on the top, and it opens this the notepad. Where you can run commands, the same command as we wrote down there, we can put here. The deadline will be I think like next Monday, like the same 1 week. 1 week, yeah. I hope it will be quite fast to correct, so then if I get it on Monday, I will be able to do this very, very fast. Not very, very fast, but a meaningful time. All right. If you have no questions, then the next assignment, the second assignment will be, I guess, I want to get it like again by Monday. So like Monday evening or like Tuesday morning, this is when you will get it. All right. Thank you. Yeah, enjoy the rest of your weekend and see you next week.